In this example, we're going to look at two problems from your homework. So in the first problem, we're given a polynomial and we're asked to find all of the rational zeros of the polynomial. So you'll also notice that it says if a zero has multiplicity greater than 1, only enter the root once. So we'll keep that in mind. So the first thing that we're going to do here is we're going to write out all of the possible rational roots. That gives us kind of a jumping off point. These are the numbers that are possible rational roots, so we don't even need to worry about any other ones. You'll remember from our previous lesson that the rational roots theorem states that if there are any rational roots at all, they're going to be in the form plus or minus p over q, where p is a factor of the constant and q is a factor of the leading coefficient. So let's look at the factors of the constant. Well, nicely for us, that's 3, so it's prime, so the factors are just 1 and 3. For q, 4 has more than just 2 factors, but it only has 3 of them. So for q, we have 1, 2, and 4. So now let's go ahead and do plus or minus p over q, and you'll remember that in the previous lesson I sort of suggested that you be methodical about this. So p over q, take every value in p and divide it by every value in q. So plus or minus p over q, we have plus or minus 1, that's 1 over 1, plus or minus 3, we've done now dividing by 1, then plus or minus 1/2, plus or minus 3/2, and then plus or minus 1/4, and plus or minus 3/4. So there's 12 total. Now, of course, I hope you remember our very first lesson that said that a polynomial will have as many roots as its degree. So 3 in this case. This is a degree 3 polynomial. So there are 12 possible rational roots. Certainly not all of them work. So let's find a rational root. You can test anything that you like. For example, if you have a really good feeling that 3/2 is going to work, you're welcome to start testing 3/2. I'm going to try -3. Not so much because I have a particularly good feeling about it. I just want to show us how that's going to go. So test -3. So remember, what are we doing here? We're asking, is -3 a root? And that's the same thing as asking, is x plus 3 a factor? So it's really, really, really handy that we have synthetic division, because all we need to do is use synthetic division and divide by x plus 3. And if we have a remainder of 0, great, it's a root. If we don't, then it's not. All right, so check it out. I have -3 here, and then the synthetic form of my polynomial. Now look, very careful. I have a skip from 4x cubed to minus 7x. I skip my x squared term. So I have a placeholder 0 between the 4 and the -7. I don't have any other skips, but I have to be very, very careful to include that 0 skip. All right, so now here we go. Sort of fingers crossed, I guess. The 4 comes down, and then multiply, add. 4 times -3 is -12. Not feeling too good about this, guys, but let's keep going. 0 plus -12 is -12. Multiply, add. -12 times -3 is 36. Too big, right? Because now when I go to add, that's 29. And remember, the goal is to end up with 0 in this last spot. There's no way when I multiply 29 by -3 that that's going to cancel out with 3. But let's do it anyway to say we did. Sure enough, 3 times 29 is 87. So this is -87, and when we add add, we have negative 84. So that's my remainder. It's not equal to 0, so negative 3 is not a root. Okay, now again, if you start testing something and you feel like, oh, this is totally not going to pan out, you actually don't have to finish it. Like once it becomes clear to you that this is not going to end up being a root, you can just kind of leave it. Now for grading purposes, of course, I have to have something, right? So you have to give me some beginnings of synthetic division and then indicate, oh, yeah, this is not going to go well. So keep that in mind. All right, so the next one I want to try, I actually want to try positive 1. I have a good feeling about positive 1. And I might have even tried that one first, except I wanted to make sure that we tried this more than one time because I want to keep exposing you to synthetic division. All right, there we go. Okay, so watch how this goes. This might be our first time getting a remainder of 0. So the 4 drops down. 4 times 1 is 4. 0 plus 4 is 4. 4 times 1 is 4. Negative 7 plus 4 is negative 3. Negative 3 times 1 is negative 3. Ding, 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 ding. Right? Like this is that super exciting moment. Yes. Since the remainder is 0, 1 is a root. Okay, so you'll notice that in the problem it says find all of the rational zeros of the polynomial. So we found 1, so might as well write it in, 1. Now, I want you to notice something. The fact that 1 is a root means that x minus 1 is a factor. Aha. And we can write our polynomial as x minus 1 times our quotient that we got from dividing x minus 1 out, which was 4x squared plus 4x minus 3. And I want to take this moment to point out this is a quadratic polynomial. And at this point in our mathematical lives, we know so much about quadratic polynomials. We can use the quadratic formula to find the roots of this, but as a matter of fact, it actually factors. So I will let you kind of play around with how exactly you work with this quadratic yourself, but I will give you the factored form. So we have 2x minus 1 times 2x plus 3. So once you are able to break down your polynomial so that the only nonlinear factor you have left is quadratic, you can use your knowledge of quadratics from there. So you can use the quadratic formula, factoring, you can use all of those things. Now check it out. Once you have it in factored form, you can see the roots. So 1 is the root of this polynomial, of this piece. 1/2 is the root that comes from that piece. And negative 3/2 is the root that comes from that piece. So we can fill that in here. 1/2 and negative 3/2. And then in factored form, I'm not going to write it in here because I don't have the room, but this is the factored form. Okay, so now let's look at another problem. Okay, so this problem, the instructions are a little bit different. It says find all the real zeros of the polynomial. And then it says use the quadratic formulas if necessary. And again, If it has multiplicity greater than 1, only enter the root once. So just like before, even though this is a different problem, you'll notice that our go-to first moment is to write out the possible rational roots. Okay, so here we go. So plus or minus p over q is what we want, where p is a factor of the constant term. Well, the constant term is 2, so that's nice. It's prime. It only has 2 factors. Actually, let me erase the pluses and minuses there. So p is only 1 and 2. And then q, those are the factors of the leading coefficient. So there's more of them this time, right? 8 is 1, 2, 4, and 8. Okay, so here goes. You'll remember that we said, and I'm not going to do this all the way through because the picture will get convoluted, but we're going to take everything in the row P and divide it by everything in the row Q. So we'll have plus or minus 1. Let me actually move this over a little bit so I have more room. So plus or minus P over Q. We have plus or minus 1, plus or minus 2, plus or minus 1/2. Now check it out. That's the 1/2 is from 1 divided by 2. Then 2 divided by 2, well, that's just 1 again, so I don't need to write it a second time. Then I have 1 over 4. Look, 2 over 4, that's just a half, so I don't need to write it again. And then lastly, looking at the 8, I have plus or minus 1 over 8. 2 over 8, well, that's just a quarter, so I don't need to write it again. So it looked like there were going to be lots of options for a second there, but it turns out there's not that many. Okay, there's a little bit fewer than we thought there would be. Okay, well, let's test them. So one thing I want to say is the problems in your homework are generally designed to work out pretty nicely. All the same, it might take you a few tries to find a root that works. And every time you come upon one that doesn't work, try to learn a little bit about what happened. So now that we're on the second example, and I am pretty sure 1 is not going to work out, I'm actually going to tell you that my sort of approach is always try 1 and -1 first, because they're going to be really quick. And oftentimes one of them works. So let's try 1. So again, I'm testing to see if 1 is a root. In other words, testing to see if 1 is a factor. X minus 1 is a factor. So I'm going to use synthetic division to divide by x minus 1. Okay, here goes. Nice thing for us here is this polynomial doesn't have any skips, so I don't need to worry about that. So let's see. I don't think it works out. I've been wrong before, but I don't think it does. Multiply, add. So 8 times 1 is 8. Yeah, it's not going to work out. -7 times 1 is -7. See, too big. Then we have -25. Yeah. So you know what I'm going to do? I'm actually not even going to keep going. I'm just going to exit out because I can already tell that when I continue on, the remainder I'm going to get is not going to be 0. Okay, let's test -1. Again, I'm not really sure that it's going to work. I don't actually think so, but I could be wrong. And 1 and -1 are both so quick that, especially when you're first starting out, it's not a bad idea to just test them. Okay, 8 times -1 is -8. -15 minus 8 is -23. See, this one comes closer. -3 times -1 is positive 23. And then -18 plus 23, oh, that's 5. But still no cigar, right? 5 times -1, that's -5. And when you add those together, that's not going to be 0. But I'm kind of liking how much better we did with the negative one than with the positive one. So for my next one, I'm actually going to use that experience, and I'm going to test the negative number first. Which one you test next is totally your call. So if you're looking at this and you're thinking, you know, I think -1/2 is going to work, then try -1/2. But I'm going to try -2. Partly because I'm reluctant to dive into the fractions. I'm kind of holding out hope that maybe, just maybe, one of the integers works out. And also it's quick to check them. Okay, so here goes. Yeah, I spoke too soon. I don't think it's going to work. 8 times -2 is -16. -15 minus 16 is -31. Yeah, see, -31 times -2, that's 62. This is not going to work because look, when I add these, I get a pretty massive positive number. And in order for it to turn out to be 0 at the end, I need a 2 here, right? So this is not going to work. So I'm not even going to finish it. Notice how much faster it goes when you don't feel yourself beholden to finishing. You're just kind of watching it and seeing what the trend is. All right, so what do we want to try next? We could try 2, right? So we could try asking ourselves, do we think 2 is going to work, right? So why not? Let's try 2. Just because just because -2 didn't work doesn't necessarily mean +2 won't work. Okay, so we drop down the 8. Yeah, I don't think this will work out. 8 times 2 is 16. -15 plus 16 is 1. Yeah, -1 times 2 is -2. See, way too big numbers, right? We need to end up with something small because, again, in order to get things to cancel out to 0, the very last thing we have to write is +2, and we're way beyond that. So the 2's have failed us. Shall we try 1/2? You can see how quickly this goes, right? And you can imagine, like, if you think back to when we were first talking about these sorts of things, and the remainder theorem and the factor theorem, you can imagine how much time it would have taken us if we were plugging things in, doing long division, and so on. So in a lot of ways, synthetic division is really a godsend. Okay, here goes. Drop down the 8. 8 times 1/2 is 4. -15 plus 4 is -11. So here, -11 times 1/2 is -11/2, which is -5.5. And this isn't going to work out, right? Because when you add those together, that's -23.5. That's way too big. I am actually going to jump on a limb here and say that -1/2 isn't going to work either, and I'm going to try 1/4. Okay. All right, here we go. And by the way, full disclosure, I didn't prepare this polynomial. I picked it at random from your homework. And that will happen. That will absolutely happen where you have to go through a bunch of them before you find one that works. So case in point, very quickly, this is starting to look bad too because, well, 8 times 1/4 is 2. And -15 plus 2 is -13. -13 times 1/4 is -13/4, which is -3 1/4. And again, I end up with a really big negative number here, and when I multiply it by 1/4, it's not going to be -2 because this is not going to be a whole number. So this isn't working well either. Okay? So you might say right now, well, what about negative a quarter? Why wouldn't negative a quarter work? How do you know? And the short answer to your question is, I guess I don't. But the fact that I'm adding 2 to negative 15, whether it's 2 or negative 2, I'm still going to end up with a number that's not divisible by 4. So I'm not optimistic about negative 1/4 either. So, well, we got here the long way. I'm hoping that 1/8 works. And if 1/8 doesn't, that negative 1/8 does. All right, so here we go. This will happen. It's annoying when it happens, but it happens. And the good news is it doesn't take too long. All right, so I'm actually going to go ahead and start with negative 1/8. The reason I'm deciding to start with negative 1/8 is that I've had better luck with the negative numbers as a rule. Okay, so here goes. Drop down the 8. Okay. 8 times negative 1/8 is negative 1. Add, and we get negative 16. Okay. Negative 16 times negative 1/8 is positive 2. Add is another negative 16. Oh, what a sigh of relief. Negative 16 times negative 1/8 is positive 2. There it is. So this is, everybody is super, super pleased now. We found a root, and the root is negative 1/8. Okay, now look, the quotient, now that we found negative 1/8 as a root, the quotient is this here, which is 8x squared minus 16x minus 16. And what's really handy here, and it's going to really help us out, is that we can factor the 8 out. And we have x squared minus 2x minus 2. Now, I hope that very quickly we can all agree that x squared minus 2x minus 2 doesn't factor. It's not possible to find two numbers that multiply to negative 2 and add to negative 2. So we're going to use the quadratic formula to find the rest of the roots. So here I go. We have 2 plus or minus the square root of 2 squared minus 4 times negative 2 times 1. So that's 4 plus 8 all over 2. So that's 2 plus or minus the square root of 12 over 2. Now I'm just going to show you, to remind you, that you can simplify the square root of 12 because the square root of 12 can be broken up into the square root of 4 times the square root of 3. So we can rewrite this as 2 plus or minus 2 square roots of 3 over 2. And since everything on top has a 2 in it and the bottom has a 2 in it, we can simplify that down. And we end up with 1 plus or minus the square root of 3. So there are our 3 real zeros, or 3 real roots. Negative 1/8, 1 plus the square root of 3, and 1 minus the square root of 3. I'm going to finish this lesson with just an observation. Note, 1 plus the square root of 3 and 1 minus the square root of 3 are conjugates. So what we're going to notice is when we have non-rational roots, whether they're real or not, they're always going to come in conjugate pairs. So in our next lesson, we're actually going to take a brief exploration outside of real numbers. We're going to look at complex numbers a little bit in our next lesson. And In that lesson, we'll talk a little bit about something called the complex conjugate. All right, see you soon. Bye.